Welcome to science class. Today we are going to talk about the erosive forces behind glaciers. Glaciers, as well as ice sheets, are unstoppable, physically erosive forces. That is, until they start to melt. Let's get started. A glacier is a solid, slowly moving unit of ice formed out of compacted snow. They are nature's bulldozers. While glaciers can't move mountains, they carve them away. Glaciers, in fact, are what make many mountains. What separates one mountain peak from another is usually the enormous ribbon of ice that has plowed through solid earth to make the valley. In many cases, glaciers flow downslope where they eventually reach warmer altitudes, become the source for rivers, and drop their sediment. Glaciers can only form in places around the world where at a certain altitude the snow never melts. This altitude is known as the Snowline. You can find glaciers in a few places in the lower 48, such as Glacier National Park in Montana, although most of the glaciers have melted, sadly. There's also Mount Rainier in Washington. If we travel north to Alaska, we can see that the snowline is very close to the base of these mountain ranges, which makes sense since Alaska lies within or very close to the Arctic Circle. In some places, the snowline is at sea level. Greenland and Antarctica and parts of South America do possess glaciers that flow all the way to the sea, which are known as tidewater glaciers. The vast majority of ice structures that make up Antarctica and Greenland are ice sheets, which we will cover after we go through glaciers. Some mountains don't have a snowline, or it makes up only a tiny part of the mountain, or such as in Alaska or Tibet, the snowline covers most of the mountain. It depends on a number of factors. At any rate, accumulation of snow must exceed what we call ablation, which means the removal of material through physical processes. The physical processes, in this case, would be the melting of snow and ice. The area above the snowline is called the zone of accumulation, and the area below the snowline is called the ablation zone. If a glacier accumulates more mass in the zone of accumulation than it loses through melting, then the glacier is advancing, moving forward. At times, a glacier can appear to be retreating. Come back in 5 years, and where the glacier ended is now farther up the valley where it begins. This can happen because of less snowfall above the snowline, but it is typically caused by warm temperatures, which cause the snowline to be found higher up the mountain. The majority of glaciers around the world are currently in retreat, melting away. Since we are on this subject, how does a glacier move? Glaciers actually flow like silly putty. The mass of the glacier deforms its shape, spreading it out. Why does solid ice do this? You should know that ice expands when it freezes. So what happens to ice when it is compressed? If ice is compressed hard enough, sheets of ice molecules slide past one another at different rates. This causes the glacier to deform and flow. It is still a solid, but it deforms under its own mass. This process is called plastic flow. The ice must be at least a depth of 50 meters before there is enough pressure for this to happen. Above 50 meters is what we call the fracture zone. The layers below the fracture zone are flowing and sliding forward, but the fracture zone can't flow with, so it becomes broken and separated. The gaps that make up these breaks are called crevasses. Glaciers also slide and shift periodically. The ice at the bottom of a glacier can be in a constant state of melting. This reduces friction and allows the glacier to do what's called basal slip. In a moment, we will go over how glaciers erode, but first we have to cover ice sheets. Physically, there is no difference between glaciers and ice sheets except for size. An ice sheet is an ice mass that is greater than 50,000 square kilometers, which is almost exactly the size of Vermont and New Hampshire put together. The largest mountain glacier outside of Antarctica or Greenland is the Baltoro Glacier, nestled between K2 and its neighboring peaks. K2 is the second tallest mountain on the planet, by the way. This glacier is 63 kilometers long, but only about 1 kilometer wide, so it's dwarfed when compared to the minimum size required for ice sheets. Ice sheets cover all land except for a few isolated peaks. They are not only extreme in terms of area, but also volume. The average thickness of the Antarctica ice sheet is almost 2,200 meters, but it's nearly 4,800 meters thick in other places. That's 3 miles of ice. Antarctica's ice sheet is like one single unit, and it's almost 14 million square kilometers. That would make it the second largest country on Earth if it were a country. Greenland looks like it's the size of Africa on a lot of maps, but that's because of the distortion that happens at the edges of maps. Greenland and Antarctica today are the only places on Earth that currently have ice sheets. There were more during the last ice age, but that's all Earth has now. Glaciers erode through two physical processes, abrasion and plucking. As glaciers advance across land, they loosen and pick up rocks. This is plucking. Continuous freezing and thawing of water beneath the glacier helps lift rocks and boulders. In some parts of the world, we find boulders that are so large and not part of the natural landscape that their presence there is mysterious. This boulder could have never been blown by the wind or water, and we know humans didn't put it there either. This boulder was dragged and then dropped by massive continental ice sheets that used to cover North America but have since melted away. Abrasion is what the rocks that a glacier carries do to the bedrock beneath. The transported rock can be ground into a fine powder called rock flour. This polishes the bedrock below. Other times, larger sediments carve grooves into the bedrock. This is how we know ice sheets used to cover North America, and the extent to which they covered it. Only a migrating ice sheet, dragging rocks across the surface of this bedrock, could form these parallel grooves. And we only find these in certain states. So that's how we know ice sheets never extended down to Oklahoma, for example. While glaciers erode, they also deposit materials, creating unique landscape features such as moraines, drumlins, and eskers. They also carve pockets into the ground, which are later filled with meltwater. I grew up in a part of the country known as the Glacial Lakes region. All of these lake basins were created by ice sheets thousands of years ago. That should just about cover the basics with regards to glaciers and the erosion that occurs in cold regions. Next time, we will switch gears and discuss the erosion that takes place in deserts. Thanks for watching.